What is going on, everyone? Welcome back to the Cloudology channel. Thank you for joining me today. Or if you're watching in the future, thank you for joining me in general. So, today I wanted to give a little introduction to containerization, what it is, how we use it in the cloud, and how it's just used in general, right? So, containerization, what is it? I'm sure it's a buzzword. If you're in the IT industry, or you're just getting into the IT industry, I'm sure you've heard of containerization at some point in time. And what is it? So essentially, you can kind of think of containerization tools like Docker, for example. Specifically, I'm going to be talking about Docker because it is the kind of the only containerization tool I've used aside from like Kubernetes and stuff like that, which also goes into containerization, but that's for another video. Um, and essentially, what containerization is, or you can think of it like kind of like a virtual machine that you can be used locally, or you can move from location to location, right? So essentially, it's a virtual machine with a very with a predefined amount of or should I say a predefined set of parameters that build your development environment or the application environment the same way every single time. So for example, if you have an application that was, I don't know, it was developed on a Linux computer, and then you give that same application code and try to run it on a Windows computer, it's going to run a little bit differently, if at all, you're going to be able to run it, right? Like, for example, let's say you have a bunch of dependencies for a React app, right? For like Node, and you install those dependencies on your local computer for whatever reason without using a package.json, whatever the case may be. Regardless, that Linux computer might have some things installed that Windows computer doesn't have installed, so therefore you can't run the application, right? Or you're going to run into issues. You're going to have spend a lot of time debugging why that code's not running versus actually coding and making changes to it. So then enters containerization, so or Docker specifically. And essentially what that does is it allows you to define how you want to run your application and declaratively kind of run it in a fixed environment, in a what they call a runtime environment. Um, and you can kind of see a little bit more about information about Docker specifically. I'm actually going to share Docker documentation right now, if it will let me. Okay. So here, this is just the Docker documentation that I have pulled up, right? And so we can give a Docker overview. I can sit here and read this to you, or the link is in my description for the link to this documentation. Um, Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. Um, with Docker, you can manage your infrastructure in the same ways you manage your applications by taking advantage of Docker's methodologies for shipping, testing, deployment, or deploying code quickly. You can significantly reduce the delay between writing code and running in production, blah, blah, blah. I can sit here and read this to you. But realistically, essentially what it's saying is it makes development easier. It makes it easier to go through the development lifecycle, and allow you to kind of like move your code that you have locally, put it on a Docker container, give it to somebody else, and they can run that Docker container. And whatever environment is spun up by that Docker container, it's going to be the same on both machines. So there's no discrepancy about what that code is supposed to look like, what it's supposed to run like, right? What is up, Christian Soto with the fire sign emojis? Thank you, sir, for tuning in today. So that's pretty much the overall general idea behind containerization, is just consistency in the environment. And what I can show you here is a Docker file, and kind of show you how basically the methodology behind it. I'm not going to get too in depth with this video. I want to do like an in depth. Basically, my next video for next Wednesday, I'm going to take a React application that I have built, and I'm going to containerize it, which is another buzzword that developers have probably heard at some point in time. And I'm going to deploy it on Cloud Run in a semi-automated fashion. So I'm going to use that Terraform code that we developed a couple episodes ago, my Terraform basic usage tutorial, my Terraform for Dummies tutorial. I'm going to take that. I'm going to deploy. I'm going to use Cloud Run instead of App Engine. And I'm going to deploy that application to a live environment where you guys can see that application actually running. So I'm going to go through that whole process on how to containerize it and how to use Terraform to launch it into Cloud Run. A lot of steps involved in that, so it's probably going to be a longer video, but I'm cool with that. But let's break down what is called a Docker file. So a Docker file is essentially like a key file that Docker, like the command line tool Docker, can pick up. So if I type Docker right here, or let's just do version. Hopefully, okay. So you can see I have Docker installed in the command line right here, right? And essentially, this command line tool can pick up this file. Specifically, every Docker file is called Docker file with a capital D. That's it. No like dockerfile.doc or dockerfile.txt or whatever. It's just called a Docker file. And what this allows you to do is define the environment it's going to run in. So since all of this is JavaScript code, chances are, and in this case, it's going to be ran with Node, right? And Node, for those of you who are not familiar, it's just basically Node is like a runtime. It's like a server for JavaScript almost. It's used to run JavaScript outside of a web browser. So you can run it on your local machine. So you're setting what environment it's going to be built with. For Python applications, this might be a specific version of Python instead of Node, but in our case, we're using JavaScript. So we're going to use Node 16, which I think is the latest version right now. Another thing you're going to define is the work directory inside of the container, right? So this work directory we're going to call /app. And essentially that's where that is the root directory of our Docker container. Because remember, a Docker container or a container is just a virtual machine, right? So that's our work directory of this virtual machine that's probably ran with like Debian or Ubuntu or something like that. I think most of them are Debian. And then we're going to copy like whatever files we need into that virtual machine. So into that container. So we're going to copy our package.json into the root directory, which we already declared as, or work directory as /app, right? And then we're going to run our npm install. And essentially that's, if you're a JavaScript developer or a React developer, you understand probably that npm install installs all your dependencies that are in your package.json. So it's going to install all of this stuff like AA, SQLite, FS, Satoshi Bitcoin, SQLite 3. It's going to just install that stuff inside of the container environment. So all of that stuff is contained, hence the word container, inside of this environment, right? And then we're going to copy everything else. So this current directory that the Docker file is in. So another note about Docker is you always want to have the Docker file in the root directory or the directory in which you plan on running your Docker commands from. Christian Soto says he knows some of these words. Excellent. I'm glad you know some of them, so I don't have to, go too nuts explaining things that are not necessarily directly related to containerization, but that's cool. So essentially what you're doing is you're copying all your code in the directory you're running this Docker command from, so where your Docker file is. So I'm going to copy all of these folders minus node modules. So our queries, our app.js is going to get in there, our package.json is going to get in there, test.js, your transaction files, stuff like that. All of that's going to get copied into the container, into this virtual environment. And then what we're going to do is we're going to the cmd command in a Docker file is essentially that is the that's the last thing you want in your Docker file, because that's actually the steps it takes to run the application. So if you look in our package.json here, we have an npm run start. So if we go to our package.json, we have our startup scripts, which is going to run npm run start, which is right here, which essentially is just going to run node on the app.js file, right? So you're just going to execute the app.js file with node, because again, you can't run JavaScript outside of a web browser without node, right? So without getting too far into the weeds with that, and essentially that's going to start your application. So if I wanted to run this app.js file, I could sit here and I could run node app.js. And it's going to tell me a module is not found because I just updated my MacBook and everything's going to be broken. So that's cool. But in a perfect world, this would run correctly on my machine, right? However, if I were to run this, so this is a graphical user interface for Docker. So this is basically an easy way to point and click and use Docker, because typically Docker is ran in the command line. But in order to kind of avoid some of this complexity, I want to run this container, which is the same thing. It's actually taking this Docker file, which already exists, and it's running that. It's executing that JavaScript, right? So if we look at this, we can see that I believe this is broken. This is a very bad example, guys, because I picked a Docker file that does not run very, very well, but that's okay. So here we can see it executed some stuff with Docker, right? So it executed that node app.js, right? It says success, connection established, table not created. Okay, so it does actually give us an output here. So it does work. Imagine that. Something I have planned actually works. It just looks really weird. So I wonder if I could open this in something that looks better. I don't use Docker Desktop too often, so you're going to have to excuse me on this one. Typically, I run everything on the command line, but you can kind of see an output here. This essentially is the output of running that JavaScript code, right? So ideally, if my local version worked, you would see the same thing. However, that's the beauty of containers in general, is my stuff is completely broken, but I can come over here to Docker and it's defined specifically, and I can still run everything and it works because it runs in its own separate environment. So it is able to run on this computer, even though I don't necessarily have the right things installed, because it's running inside of its own environment. And so that's why Docker is pretty awesome to have. And a little bit of background on like containerization in general. So essentially, like, I guess the life cycle of how it works is Docker will do what's called building an image, right? So it will look at this Docker file and it'll be like, okay, anytime I'm going to create what's called an image, which we have right here, and we can see in this Docker desktop right here. It basically took a snapshot of that Docker file and is like, okay, anytime someone calls on this image, I'm going to create this specific thing, right? And that's what an image is. And you can share this image anywhere. So you can like send this image to like Docker Hub. You can use it in AWS. You can use it in GCP, Azure. You can send this image, to someone else, or for someone to pull that image from somewhere else. You can make it publicly available, whatever the case may be. You can pull it from what's called a registry, an image registry. And if that image is pulled and then that container is built off of that image, it's going to run the exact same way as when this Docker file back here was written. So it's always going to execute these set of commands every single time, and it's going to run the application to look the same every single time, no matter what. So that's you can see how that is pretty advantageous for deploying your code in different places. For example, if you want to move your application from one cloud platform to another because of certain specific reasons, possibly maybe one of them decides they don't like your application anymore. Well, guess what? You can easily take that image and put it somewhere else, just like that. It's literally that simple. The only thing you'd have to set up is like any environment variables that you were using, or external things not necessarily containerized in your app. But the beauty of it is you can define all that stuff inside of a container as well. So this is just a super simplified version of containerization and Docker specifically. You can get really into the weeds by using like Docker Compose, and that's like a YAML descriptor of like how to build certain containers. So, for example, if I wanted to test this application before sending it somewhere, or I just wanted to test the application like automatically, right? Well, basically, what I could do is I could run this application, or run that container, and then run another container that runs my tests against the other container, right? So essentially, you see how this services keyword is here? You can have more than one container running inside of this Docker Compose YAML file. I'm not going to get too crazy into this because this goes into like continuous integration and continuous development, which is a whole nother topic entirely. But for right now, we're just going to focus on containerization. Basically, I want you to take away from this that it is not difficult. If you're writing code and you need to deploy it, this makes it extremely easy. Um, you don't have to configure anything. It's so traditionally, the way applications used to be ran before containerization kind of existed. I think, I don't know. I haven't been in the business that long, so I can't really tell you. I wasn't there when it was written, so to speak. But typically what you would do is you would spin up a VM, kind of like we did in my Terraform for Dummies tutorial. So you would spin up a VM and you would probably enter that virtual machine via SSH. So you would connect to it and then run whatever commands you need to actually run your application. Or maybe you had a script that did that for you, right? Well, this prevents this. Basically, you know you don't have to do it that way. You can do it that way, but you don't have to do it that way. And it's a little bit faster to deploy applications if you use a container, because all you have to do is point a service to that image and say, hey, take that image and then build whatever's on it and then host it. And that's exactly what we're going to be doing next week, which I'm pretty excited about, because I'm going to literally show you an application that I've previously written. I'm going to containerize it, which I haven't done before. So we're going to, probably going to run into some bugs, and we're going to run into some issues. And then I'm going to containerize it, and I'm going to deploy it live on a website where anybody can access it, right? It might not have the greatest functionality ever. I don't think it has any functionality, actually. But that's fine. It's just to demonstrate the example of how we typically use containers in the cloud. So how we deploy applications typically. Now, granted, not every place does it like this. Not every place uses containers. For example, if you work in the federal space, you're probably not using containers because the federal government is afraid of containers. I don't know why. I mean, they don't like the fact that containers can just be randomly named things. So it's another fight for another day. But if you're a developer and you want to quickly deploy your application, I would look into using Docker, because you don't have to worry about different machines having different things that needed to be installed, different dependencies. You can just give it a container image, and it'll pull it and deploy it for you. So with that in mind, I hope this was a little bit more insightful. And like I said, come back next week, because I'm going to do a full tutorial to walk through like how to deploy your application in a live environment, and basically walk you through it step by step with React, because I know React relatively well. So I think it's the easiest way to do it. It's a popular language. It's getting more popular with Web3. So with that, I will see you guys later, and thank you for joining me.